Hello everybody, welcome to lesson 2 of unit 5, and in this lesson we're going to cover operator overloading, which is found in chapter 13 of the text. And this might be something that many of you never heard of, but the concept isn't very difficult to get the hang of once you understand the fundamentals and the syntax. We're going to talk about what operator overloading is, how to overload some common operators, and then finally we'll introduce a special pointer called this. After this lesson, you should be able to overload basic operators for your own classes, overload input and output operators, overload increment and decrement operators, and finally be able to use the this pointer. And we'll get into that towards the end. So what is operator overloading and why do we do it? Well, let's use the clock type class as an example. Here we're going to call a few member functions to print the time, increment the time, and compare two time objects. What about this segment of code which does the exact same thing? Which version do you prefer? Personally, I think that this is a lot more concise than having to write out all these methods, don't you? The assignment and member selection operators are the only built-in operators on objects of class types. Operators are treated as functions by C++, and C++ allows you to overload an operator, which extends the definition of an operator to work with a user-defined data type. And operator overloading is one of C++'s most appealing attributes because it allows you to write that more concise code. So what does it mean when we say that C++ treats operators as functions? Well, as you know by now, this is how we call a member function on an object. But what does it mean if we try to add two objects together, like this? It doesn't really make much sense, does it? What does it mean when we add object A to object B? Object A plus object B is interpreted by the C++ compiler in one of two ways. The compiler first looks for member function to call operator plus in the class of which object A is an instance, right? So it's going to look for a method called, or a function, called operator plus, which is going to tell it how to add these two objects together. And here's the UML for such a member function. You can see in the member function section right here, we have an overloaded plus operator that takes one parameter. If such a member function is not found, the compiler looks for a standalone function that takes two parameters of the appropriate types. Don't worry about the friend keyword here, we're going to get to that in a little bit later, but it's important to note that the return type and the formal parameters don't have to be the same type. It should be whatever makes sense for the operator functionality that is desired. For example, if we wanted to add object A to an integer, then we might describe or declare a standalone non-member function that takes a object of that class type and an integer, right? And maybe you want the result of that addition to be some other thing, and that's where you would change the return type. But it's very common to at least have a, class 1, plus class 2 equals class 3, all of the same class. So let's take a look at how we overload an operator as a member function of the class. Here you can see our declaration for clock type, and we include our function equal time, and here's the implementation for equal time. We can instead overload the equal operator to achieve the same purpose. So here you can see we are now declaring the equal operator, and here's our implementation for it. And you can tell that they are virtually identical except for the name of the function. That's it. That's all it takes to implement the operator overloading inside a member function. Pretty simple, isn't it? Now that we have it implemented, we can use the equal operator to compare two objects of clock type. Pretty cool, huh? You can see it here. We're comparing my clock to your clock. So let's explain how this works. The left-hand side operand my clock right here is the calling object, and the right-hand operand, your clock, is passed in as the parameter, right? So my clock is what's calling the equal operator, and your clock is what's getting passed in as the parameter. In fact, this code right here is equivalent, and it will compile just like this one does. So these two things are the same. When we overload a binary operator as a member function, the left-hand side operand is always the calling object, and the right-hand side operand is always the parameter. You can also overload an operator as a non-member friend function, like this. And the way you do it is to declare inside the class that I have a friend function. And you can see here that it has a friend modifier. Being a non-member, and remember that a friend is not a member, public and private modifier doesn't apply. Another thing to pay attention is that the operator function now takes two parameters. So you can see here we don't have public or private, and you can see that we have two parameters as well. And because a friend function is a non-member, it doesn't have a calling object, therefore both operands have to be sent in as function parameters. So that's the declaration. Now let's take a look at the implementation. And you can see here that the function isn't a member of the clock class. We have no scope resolution operator. We have no clock type, colon operator. We just have the function name. This function directly accesses the private data members of parameters clock1, C1, and C2. And that's the benefit of being declared a friend, is we are telling the compiler that even though this function doesn't belong to clock type, we're going to allow it to access all of our private data members. And you can see here that the operator is still used in the same way. But now the compiler interprets this as a call to operator equals equals with the two parameter construction. Be aware that a function cannot make itself a friend of a class. That declaration has to come from the class itself. So the class has to tell the compiler, hey, when you see this function here, it's a friend of mine and it has access to my parameters. I can't say anything down here in its implementation that I have access to this class type's data members, so the private data members. Okay, it has to be done inside of the class that is granting permission. Now, this seems like it's a pretty cool concept, but you have to remember that this breaks encapsulation of the class by allowing direct access to the private data members. And for that reason, you should use it cautiously. I mean, that's the whole one of the reasons for using classes is, data protection and encapsulation. This link here has a good discussion of the pros and cons of using a friend. So I recommend you go out and take a look at it. There's a lot of good information on why and when you should do it. Now, another thing I recommend doing at this point is stopping the video and go ahead and practice implementing the code that you saw in this video and trying it out on yourself to make sure that you can figure out how to overload a function as both a member of a class and as a non-member friend function. Because if you don't practice it, you're not going to remember it. And this leads us to our third option, which is overloading as a standalone function. You can see here the declaration outside of the class declaration. Here's the class, and here it is outside of it. And a standalone function is not a member, so again, there's no calling object, so therefore both operands have to be sent in as function parameters, which you can see here with C1 and C2. The implementation now requires some getter functions since it can't access the private data members of the class. So here you can see it calling it, and here you can see what we've declared the getter functions. This operator is still used in the same way, and the call translates to a standalone function with two parameters. So here you can see here's how we actually use it, the same way that we used it before, and this is what the compiler sees, right? It sees this operator function with the two parameters. Overloading an operator as a standalone function seems less convenient because we have to make sure we have the getters and setters. However, it's considered a better style since it maintains the encapsulation of the class. And again, I recommend you trying to implement this on your own as practice so you can get the feel for it. So you can use some of the other operators like less than or greater than, since they compare very similarly to the equal operator.
Many operators can be overloaded as either member or non-member. For encapsulation purposes, the non-member non-friend version is preferred over the friend version when we overload an operator as a non-member. Remember, we looked at the string class before and its non-member functions in the last lesson. Now we understand what those operators are. They are all overloaded as non-member functions. In fact, if we just look at the plus operator, we can see that it's overloaded in many ways to allow for a wide variety of circumstances. And don't worry about this double ampersand notation like these. They are an R value reference, and it's not covered in this course, but you can feel free to look them up on your own. I just wanted to point out that there's something that's a little bit different there that you haven't seen before. But the whole point of this was just to show you that this plus operator is overloaded many different times to handle the different inputs that are required. Given a binary operator which takes two operands, we can overload it as a member of the class of its left-hand side operand. The left-hand side operand will become the calling object, therefore it only needs one parameter. When we overload it as a non-member, that means it doesn't belong to the class, either friend or standalone, both operands are sent in as function parameters. The left-hand side operand is the first parameter, and the right-hand side operand is the second parameter. Okay, so this is just a recap. Left side goes to the first one, right side goes with the second one. Given a unary operator, which takes a single operand, such as the increment operator, we can still overload it as a member in which the operand becomes the calling object, so it takes no parameters. If we overload it as a non-member, that operand will be its only parameter. So you can see with operands like this, where there's only one operand, there's not a left and a right, there's just one, then as a member function, it takes no parameters because it's the calling object, and as a non-member function, it takes one parameter because there is no calling object. Now, some operators can only be overloaded as members, such as assignment and compound assignment operators. And some operators can only be overloaded as non-members, like the input operator and the output operators, which we're going to cover next. And here's the class diagram for the old clock type class. And here's the new class diagram with the operator overloading. The equal operator replaces the equal time function. So this is nothing new. We're just showing you what the UML would change, or what the change in the UML would look like if we implemented the operator instead of the function. So let's take a look at those input and output operators that we talked about previously. The overloaded output operator will allow us to output a clock type object the same way we would output a number or a string, like this. This is the class diagram annotation for a friend. From this entry, we can tell that the output operator takes two parameters. The first, a reference parameter of OStream type, and the second, a const reference of the type of object you want to output. Its return type is a reference of OStream. So let's talk about the OStream type first. Back in Chapter 3, we used the output file stream class for file output. The output file stream class is a child class of the OStream class. Therefore, if we want our output operator to work with both cout and any output file, we need to use the parent class OStream. We need to use this one right here. Similarly, we use ifstream, or input file stream, for input files. ifstream is a child class of istream, and cin is an object of the istream class. If we want our input operator to work with both cin and any input file, we use the parent class istream. So now let's get back to overloading the output operator for the clock type class. Here it's its declaration as a friend. The first parameter is OStream type, so it can both work with cout and any output file type objects. We pass this parameter by reference instead of a const reference because it's an in-out type parameter. As an input, it should have been initialized to a valid OStream object when this function is called. And by the end of the output of this function, the OStream parameter will have been modified after we output data to it. Okay, so So again, this is the stream that we're taking in, this is the stream that we're returning, and we're going to modify it with this clock type, but we're not going to modify clock type at all. We're just going to be printing it out to the output stream, so it's going to be const, which means we're not going to be modifying it. The output operator returns a reference O stream. This allows for cascaded output calls. You might remember this as method call chaining from Java. For example, when we output multiple items in one output stream, it actually outputs the first item and returns the modified OStream object itself. This OStream object is then used for the next output call, which returns the modified OStream object again, and so on and so forth. And this is how cascaded output calls work. We covered the declaration and its use. Now let's examine the implementation of the output operator. And it's the same as what the print member function would do, except for that the output is done with the OStream parameter, and you just need to add a return to the end to return this OStream parameter, right? And that's it. That's how you overload the output operator as a friend of a class. Remember, we know it's a friend because we don't have the clock type here with the scope resolution operator, and we can see that inside the class type we are declaring this function as a friend. Earlier we said overloading as a standalone function is a better style compared to overloading as a friend due to the breakage of encapsulation. So what do we need to do to change this into such an overload? Well, we won't be able to directly access any private data members like this. So really, all you have to do is substitute the direct access with a call to a getter function and move the function declaration out of the class. You can review the section on overloading as a standalone function earlier in the lesson if you need a refresher on how to do that. The input operator returns a reference of iStream, which allows cascaded input calls. And here's the implementation for the input operator. The second parameter, the class object, should receive a new value via input. It is therefore an out type parameter and needs to be passed by reference. This function will input enough data for the clock type object and then return the input stream object at the end. So take a few moments to understand how this code works. So using this input from the iStream, we're going to read in the 12, and then we're going to discard the colon. Then we're going to read in the 12, and then we're going to discard the colon again, and then we're going to read in the 30. Each time doing proper input validation to make sure that our numbers are logical, meaning between 0 and 24 for our hours and 0 and 60 for our minutes and seconds. And here's an alternative implementation. And I'm only using single line if statements for the sake of screen real estate, so like right here. So pause the video and find out the differences between this version and the previous version. And I'm waiting. Okay, hopefully you paused it. How much did you get? Well, this version uses local variables to hold input data instead of directly storing them in the data members of the object. This version also checks input failure and returns right there. Finally, if all inputs are valid, then it will update the object with those inputs. So with this new version, what would happen if we gave it an invalid input? Well, you can see here we've got a driver program, and we're not going to show you all the details to it. But if we gave it an invalid input, you can see here we're giving it an invalid input of 4EF39, which is not a time, right? So with the new version, instead of setting the clock where the original version, it would have gone ahead and set the hour to 4, and then it would have left 24 the same, and then 39. In this instance, since it got an invalid input, it didn't change the value at all, which is kind of what we expect. Now, both versions handle invalid input in some way. The textbook version satisfies the basic exception safety that a fail operation may cause a side effect. You can see from this output that part of the clock time was modified. But is this what we would really want? And I already answered that question. It's no. The alternative version satisfies strong exception safety in that the failed operations are guaranteed to have no side effects. We haven't modified the clock time after inputting an invalid time. For this version, either input will be successful and the object will be filled with new values, or the object will not be modified upon any invalid input. Those two levels of exception safety are extra material. You're not going to see a question on this on the test, but you may see those different types when looking at C++ function documentation. So for us, the lesson is that we should expect and handle invalid input in some way if we overload the input operator for a class. All right. This is the preferred behavior, strong exception safety, but this is also an acceptable version. Next, we'll look at the unary operator, the pre-increment operator. The meaning of pre-increment is that the increment will happen first and the new value will be returned. This is the same as it is in Java. We're overloading it as a member function here, so it takes no parameters. The return type of the increment operator matches the class. You can see that here. This is the return type. This is the function with no parameters. The increment operator may be used by itself or embedded in another expression. So you see here we're using it alone, and here we are using it as part of another expression, right, where it's going to increment my clock and then return the result and store it in his clock. And here's the implementation, which increments the calling object. The data member seconds is incremented, and any possible carry is passed into minute or hour, depending on if the minute carries over. And this is just what the old increment second member function does. We need to get a hold of the calling object and return it at the end as it was the object we just incremented. And we do that by using the this pointer. In C++, the calling object of a member of a class is pointed by a special pointer called this. If you trace the execution into this increment operator or any member function call, you will be able to see pointer this, and is a pointer of the specific class type. So you can see here we have clock type pointer. Now remember that in C++, this is a pointer, which means that you need to dereference it in order to access the object. That's why we have to return star this at the end of the operator. In contrast, the this keyword in Java is a reference. You can directly access the object it points to without any dereferencing. Here you can see that the this keyword can be used to call the default constructor and to represent the calling object. So, to summarize, in Java, you don't need to dereference because it's already a reference. In C++, this is a pointer, so you need to dereference it to access the object using the dot operator. Just like the output operator, we can overload the input operator as well. So let's look at how to do that as a friend. So here's the declaration, and you can see it's very similar to the output operator. The first parameter is an iStream type, so it can work with both cin and any input file stream objects. The input stream parameter is also an in-out type and thus needs to be passed by reference. And it needs to be initialized as to a valid input stream object when the function is called, and we will be modifying it after we extract data from it. Because remember, we're going to read something from it and take that out of the stream, and then we're going to pass that stream on as a return type. So we've talked about overloading the pre-increment operator as a member, but what about the post-increment operator? How would we overload that? The function declaration of a post-increment looks the same as a pre-increment operator. So C++ adds a dummy integer parameter to posting. So here you can see the pre-increment and here's the post-increment. The compiler will then translate a call of the post-increment into operator ++ with a integer argument of 0. Post increment returns the original value and then increments. So in this implementation, we are leveraging our pre-increment operator. And in this case, you can see that we are creating a new clock type object called temp, and we are assigning it the values that are stored in the calling object. We are then incrementing this object, right? We're dereferencing it, and then we are calling our pre-increment operator, and then we're returning our temporary object, which has the same values as our clock type. Again, this is where it gets a little bit confusing, but remember, with the post increment operator, we're returning the object first, or the values of the object, and then we are incrementing it after that. And that's why we have to store this temporary variable, or why we create a copy of it rather, storing the current values and return that after we increment the values, right? So this kind of takes a snapshot in time of what the values currently are, and then we return that. But before we return that, we're incrementing this one. Now, you need to be aware about compound operators. The overloading for the binary plus operator, for example, doesn't imply that the compound operator plus equals is overloaded. In order to use this compound operator, you need to overload it explicitly. So you have to do operator plus equals and then define what that is. Finally, some operators cannot be overloaded at all, such as the dot operators, the scope resolution operator, the conditional operator, and the size of operator. Overall, use operator overloading when it makes a program clearer than accomplishing the same task with function calls. It does involve a bit of work to do it properly. Not a lot, because you have to go through and do the functionality anyway, but you just have to think about things a little bit differently. This lesson might have been a lot to take in. Again, the concepts aren't particularly difficult, but they can be challenging when you're new to it. As a recap, what you should have taken away from this lesson, aside from the syntax specifics that we presented, was that C++ treats operators as functions. And we can overload an operator to have it work with user-defined data types. We looked at many examples of operator overloading in this lesson, and many operators can be overloaded as either member, friend, or standalone functions. Some operators can only be overloaded as members, such as the assignment kind, which we will examine in another lesson. Some operators, such as input and output operators, can only be overloaded as non-members. And finally, we close with the implementation of the increment and decrement operators. Well, we covered the increment, but decrement's the same, just subtract instead of add. And we talked about some words of caution around using compound operators and which operators can't be overloaded. So remember, take time to practice these concepts, actually go through and try to overload an operator on your own with your own user-defined class. You will thank me for it because it takes practice doing it over and over. And with that, I will see you in the next lesson.